Okay, let's unpack this. Imagine a future where we don't just create new energy. Instead, we cleverly reuse resources we already have.
Right
I'm
on.
talking about existing nuclear
Right.
waste.
Taking something that's seen as a problem,
Exactly. And then using that to make clean, reliable power. Power for the really energy-hungry parts of our world today, like, data
which
centers.
are just booming.
Absolutely booming. And that compelling story, that's really at the core of what Oklo Energy is trying to do.
Well, what's really interesting here is how they're sort of positioning themselves. They're tackling two huge challenges at once.
Which are?
Well, first, the massive global need for clean energy, driven a lot by things like AI now.
Hmm.
And second, the really complex long-term issue of how we manage nuclear waste.
Right, that dual challenge. And that's exactly why Oklo is the focus of our deep dive today. We've got quite a stack of sources, actually, including some reports originally in French, which were insightful. They lay out Oklo's vision, their tech, the markets they're aiming for, where they stand right now. So our mission, like always, is to sift through all this material together, pull out the key insights, and basically give you a shortcut to understanding what Oklo is up to. Its potential impact and the really crucial details you need to get.
Yeah, and we'll definitely be exploring their unique technology. That's centered on the Aurora reactor and its ability to use recycled nuclear waste. That's a big piece.
Okay.
And we'll dig into their strategy, focusing on those critical, high-demand customers, data centers especially.
Such a huge topic right now.
Oh, unquestionably.
Mm-hmm.
And we'll also look at the bigger picture of the role Oklo could play in the U.S. energy system, contributing to national energy security sustainability goals.
Makes sense.
And finally, we should highlight the partnerships they mentioned, their competitive advantages, regulatory stuff, all the things the sources see as foundational to their plan.
Yeah, and it's important context right up front. The sources are clear. This is a company still in the development phase.
Yep.
They are pre-revenue now, but they have some pretty concrete plans, targets for getting things running in the, well, relatively near future.
That's right. I mean, their Q1 2025 report confirms that pre-revenue status. They showed a net loss for the quarter, which makes sense. They're investing heavily in R&D.
Sure.
But the sources also point out they have a substantial amount of cash on hand, over $260 million. That's funding this development.
Okay, so they have runway.
Seems so. And the target time frame for actually deploying the first units, according to the material, is looking like late 2027, maybe into early 2028. So yeah, not operational yet, but aiming for commercial activity reasonably soon.
Okay, let's really get into the nuts and bolts then. What is Oklo actually building? You mentioned the Aurora reactor. What exactly is that? How is it different from, what people might typically think of when they hear nuclear power?
So the sources describe Oklo as specializing in advanced fission reactors, specifically compact fast reactors.
Fast reactors.
Yeah. The Aurora is their main design. It's engineered to be, well, pretty small, modular. It can generate anywhere from 15 up to maybe 50 megawatts electric. That's the power output.
Right.
And it uses what's called a fast neutron spectrum. That's different from the thermal spectrum in most traditional large light water reactors.
And why does that matter, the fast spectrum?
It's key because it lets the reactor efficiently fission different kinds of atoms, different isotopes.
So it's an SMR, a small modular reactor, but a specific type, a fast reactor SMR.
Precisely. And here's where it gets, well, really interesting and what sets Oklo apart, according to these sources anyway.
Okay.
The Aurora reactor is specifically designed to be fueled by recycled nuclear waste.
Wow, okay, recycled waste.
Yeah, this isn't just some side feature. It seems fundamental to their whole approach.
Yeah.
Traditional reactors leave behind spent fuel. It contains various isotopes, some highly radioactive, long half-lives.
The stuff everyone worries about.
Exactly. Fast reactors, like Aurora is designed to be, can actually use some of those long-lived isotopes in the spent fuel. They essentially burn them to produce energy.
So wait, they're not just making power. They could actually be reducing the amount and sort of long-term danger of the existing waste pile.
That's the goal. And it's a pretty significant one, right? It potentially turns this liability, all this stored spent fuel, into an actual resource. And this helps tackle that huge national challenge of nuclear waste management, while also providing fuel that doesn't need, fresh uranium mining and enrichment in the same way traditional plants do.
That makes sense.
And the sources mentioned Oklo acquired a company called Atomic Alchemy. Seemed like that was to boost their capabilities in exactly this area, fuel recycling tech.
Okay. And what about safety? Nuclear always brings up safety concerns. The sources mentioned inherent safety features.
Yes, the material really emphasizes that, the inherent safety characteristics of Oklo's design.
What does that mean, inherent?
It means building in passive safety mechanisms, things that rely on basic physics, like thermal expansion, convection, to keep things safe, even if something goes wrong, rather than relying only on active systems that need power or someone to flip a switch.
So it kind of manages itself to a degree?
It's designed to be self-regulating to a significant degree, yeah.
Okay, so compact, fast spectrum uses recycled waste, inherent safety, and didn't they get some kind of recognition for the design itself, something about how it looks?
They did, yeah. The modular design of Aurora, they actually worked with the architecture firm Gensler on it, was recognized, apparently for its simplicity, maybe even aesthetics.
Interesting.
And this reflects a design philosophy aiming for, easier, faster construction, potentially lower costs compared to those enormous, complex nuclear plants we usually picture.
Right.
And they have made some tangible progress on the regulatory front, too. The sources note they got a site use permit from the Department of Energy back in 2019 at Idaho National Laboratory, and even received some initial fuel material for their first planned unit there. Now, navigating nuclear regulation is, well, notoriously difficult.
Understatement.
Yeah, but this early progress is definitely highlighted in the sources as a positive sign.
All right, so they have this innovative tech. Who are they actually planning to sell the power to? You mentioned data centers earlier, and the sources seem to hammer this point home. Why is that market such a huge focus for Oklo?
This really speaks to the just massive shifts happening in energy demand. Data centers, fueled by everything from cloud computing to the explosion in AI.
Right, AI again.
They're becoming incredibly power hungry. The sources cite these projections. Data center electricity use is expected to grow like 10% per year through 2030.
Wow.
It's jumping dramatically from around 35 gigawatts in 2022.
Yeah.
This isn't just steady growth. It's like accelerating demand on a scale we haven't really seen before.
Yeah, you hear so much about AI needing the computing power, but the energy side of that often gets less focus.
Exactly. And data centers don't just need a lot of power. They need power that is incredibly constant and reliable, like 247, zero downtime reliable.
Can't have the cloud going down.
Precisely. And intermittent renewables, like solar or wind, while obviously essential for decarbonizing, they need significant battery storage or backup to meet that kind of constant, high-quality demand. Nuclear power, though, with its ability to just run continuously for very long stretches, it's inherently really well-suited for that kind of baseload reliable power.
And Oklo's reactors are low carbon, right? So that helps the data centers meet their own green goals.
Absolutely. Nuclear generation is zero direct emissions electricity. That's crucial for tech companies who've made these big commitments to reduce their carbon footprint. The sources estimate that just one Aurora reactor could save like 1 million tons of CO2 emissions over its life compared to using fossil fuels.
Plus, you said they're compact and modular. Does that mean they could potentially put the power source like right next to the data center?
That seems to be a key part of their strategy, yeah. A major advantage they highlight. The modular design allows for potential on-site deployment.
Okay.
And that gives data centers significant energy independence, boosts their resilience, makes them less vulnerable to grid outages or, fluctuations.
Right.
The sources even mention specific features like black start capability. That means the reactor can start up without relying on grid power, which is vital after an outage.
Ah, okay.
And the ability to operate in island mode, where it just powers the facility, totally independent of the main grid. These are critical things for mission-critical operations like giant data centers.
So reliable, low carbon, potentially right there on site, built for resilience. Okay, yeah, I can see why data centers are a prime target. Did the sources mention specific deals or agreements with data center companies?
They did, and these kind of give you a sense of the potential scale they're looking at. The sources talk about a total customer pipeline exceeding 14 gigawatts overall.
14 gigawatts.
Yeah, potential pipeline. Within that, they detail some significant commitments, specifically from the data center world. They've apparently secured letters of intent LOIs from 2 major data center providers.
Okay.
For up to a combined 750 megawatts of low-carbon power.
750 megawatts just from 2 potential customers. That sounds substantial.
It is. And then they also have what's called a pre-agreement. It's non-binding, but it signals serious interest with Equinix, another huge global data center player.
Right. I know Equinix.
That's for up to 500 megawatts. And add to that an LOI with a company called Wyoming Hyperscale for 100 megawatts for a data center campus they're planning.
Okay, so if you just add up those specific data center ones you mentioned.
I'd say 750 plus 500 plus 100. It says over 1,300 megawatts, 1.35 gigawatts, specifically aimed at data centers.
Wow, that really underscores the demand, doesn't it? And the potential market size just in that sector.
It really does. And these potential deployments, they're planned for various places. Idaho, Ohio, Texas, Wyoming are mentioned. Using those 15 megawatt and 50 megawatt reactor units, deployed in phases probably, as the customer needs grow, it paints a picture of a very focused strategy on this high-demand, high-value market.
You mentioned other potential customers, though. There was a partnership with Diamondback Energy mentioned.
Yes, exactly. Showing it's not only data centers, though that's clearly a huge focus. They have an LOI with Diamondback Energy.
An oil and gas company, right? Permian Basin.
That's them. To provide 50 megawatts of power for their operations there, which are very energy intensive. So that highlights potential in other industrial sectors too.
Okay.
And they've also announced some collaboration with Korea Hydro Nuclear Power, KHNP, on technology development.
Interesting. Okay, so we have this unique tech, a clear focus on these power-hungry customers like data centers, backed by some significant potential partnerships. How does all this fit into the sort of bigger picture, the national energy strategy?
Yeah, looking at that bigger picture, Oklo seems to position itself as contributing significantly to strengthening the whole U.S. energy landscape.
How so?
Well, by developing and, if successful, deploying these advanced modular reactors that can use recycled fuel, they're helping diversify the energy mix. That reduces reliance on fossil fuels, obviously.
Right.
And it provides a constant, reliable power source that can complement intermittent renewables like solar and wind. That's really crucial for grid stability as we go through this energy transition.
So they're part of the clean energy transition, but providing that steady, always-on power that's needed.
Exactly. That's the idea. They also enhance energy security. The potential to deploy these compact reactors right on site at critical places, data centers, industrial plants, maybe even defense installations. The sources mentioned discussions with the U.S. Air Force.
Oh, interesting.
That strengthens national resilience, energy independence, less reliance on vulnerable long-distance transmission lines, perhaps.
And that whole turning waste into fuel thing, that seems like a national benefit too, beyond just the energy part.
Oh, absolutely. Managing and storing nuclear waste long-term is a major, major national challenge. And expensive.
Yeah.
Oklo's approach, recycling that waste into productive fuel, directly addresses this. It maximizes how we use resources and could potentially reduce the burden of long-term storage. Their proposed Aurora fuel fabrication facility at Idaho National Lab is key to that strategy.
And does this align with what the government is trying to do? Current policies?
It seems so. The sources explicitly state that Oklo supports federal initiatives aimed at speeding up advanced nuclear development and deployment.
Okay.
They reference support for recent executive orders focused on, advancing U.S. nuclear leadership and fuel security. This alignment, plus their early regulatory engagement, are actually listed as key competitive advantages for the company in the material we looked at.
Okay, let's dig into those competitive advantages a bit more then. We've talked about the waste recycling, the regulatory alignment. What else makes Oklo stand out, according to these sources?
Well, the inherent safety features we discussed, those are highlighted again. The modular design's simplicity is seen as helping with easier deployment.
Right.
But a key advantage they really seem to emphasize is their business model, a direct sales approach, specifically selling the energy directly to customers through long-term power purchase agreements or PPAs.
Ah, so they're not just selling the reactor itself, they're selling the power output. Like they become the utility for that customer.
Precisely.
Yeah.
That seems to be the plan. So instead of a customer, like a data center company, having to buy a reactor, figure out licensing, build it, operate it, which is, massively complex.
Yeah, I can imagine.
Oklo plans to handle all of that. They own and operate it and just sell the reliable power output to the customer under a long-term contract, a PPA.
Okay.
This makes things way simpler for the end user, right? It gives them cost predictability through the PPA and potentially de-risks their energy supply.
Yeah, that makes a lot of sense why a data center company would find that PPA model really appealing. Avoids a huge headache.
Exactly. And this model contrasts with, more traditional approaches where big utilities own and operate huge plants, or maybe where customers might think about buying and running smaller generators themselves.
Right. Are there competitors mentioned?
The sources mention competitors generally. For example, NuScale Power is brought up. They develop light water SMRs. But they position Oklo as a leader, specifically in the fast reactor space,
Right.
and that integrated fuel recycling approach,
Gotcha.
which Oklo argues, provides these distinct advantages, especially for customers interested in using waste or maybe needing smaller, faster deployments.
And the company itself, founded by folks from MIT, I think? And wasn't there a connection to Sam Altman mentioned in the sources?
Yes, that's right. Founded by Jacob DeWitt and Caroline Cochran, both MIT grads. And Sam Altman, probably best known as the co-founder of OpenAI.
Right.
He serves as Oklo's chairman of the board until April of this year, 2024. The sources note his resignation was apparently to avoid any potential conflict of interest,
Conflict of interest, how? Yeah.
given possible future energy supply deals between OpenAI with its, immense energy needs for AI computing and Oklo.
Ah, okay. That connection itself really highlights this convergence we're seeing, doesn't it? The tech world, especially the AI boom, isn't just about chips and software anymore. It's fundamentally about securing huge amounts of reliable power.
It absolutely does.
Yeah.
Altman's involvement, even though it ended because of potential business dealings, it just underscores the strategic importance that major figures in the tech sector are placing on energy supply for their future growth. It reinforces why reliable, clean, potentially independent power sources are becoming such critical infrastructure for the future of AI and computing.
Okay, wow. We've covered a lot in this deep dive. We've explored Oklo's pretty unique technology using recycled nuclear waste in their Aurora reactor. We've seen their very sharp focus on powering these energy-intensive customers, especially data centers, backed up by those significant potential agreements.
Yeah, those LOIs and pre-agreements.
We've talked about their intended role in the bigger national energy picture, enhancing both sustainability and security.
Right. Diversifying the grid, potentially tackling the waste issue.
And we looked at the competitive advantages they highlight, from inherent safety and that waste recycling angle to their direct sales PPA model and the modular design.
Exactly. The sources paint a picture of a company with certainly innovative technology and a clear market strategy, supported by some promising early agreements. But as the sources also implicitly acknowledge by noting their pre-revenue and giving those target dates, the really significant work of final licensing, construction, commercial deployment, that all still lies ahead.
Absolutely. So, distilling all this analysis from the sources, what are the key takeaways for you, the listener, to keep in mind?
Well, first, I'd say Oklo's core innovation, the Aurora reactor. It aims not just to produce energy, but to tackle the nuclear waste challenge head-on by using recycled fuel. And that capability is linked to its fast reactor design. Okay. Second, their very deliberate strategic focus, providing reliable low-carbon power specifically to energy-hungry sectors like data centers. And that's evidenced by those substantial LOIs and pre-agreements with major players we discussed.
Right, the Equinix and Wyoming Hyperscale example.
Exactly. Third, Oklo is positioning itself to contribute to the broader U.S. energy landscape, adding a reliable, non-emitting baseload source, enhancing grid resilience, supporting federal nuclear goals, partly by using that challenging existing waste resource.
Makes sense. And
Fourth, their potential edge seems to come from a combination of things. Those inherent safety features, the unique waste recycling model, their direct sales PPA approach simplifying things for customers, the regulatory progress they've made so far, and the modularity of Aurora, designed for simpler construction.
good summary.
But it really bears repeating. While the potential and the partnerships outlined in the sources are significant, maybe even exciting, the company is still in development. They're targeting deployment in late 2027 to early 2028. And the path from concept to commercial operation in the nuclear world is always complex.
No doubt about that. All of which brings us to this final provocative thought for you to consider. Given this accelerating global demand for power, driven especially by disruptive tech like AI and massive computing needs, and given the ongoing, really difficult challenge of managing nuclear waste, can companies like Oklo successfully navigate all the regulatory and construction hurdles to actually scale their innovative approach?
It's like a big question.
Yeah, and if they can, what would that truly mean? Not just for cutting emissions or solving the waste problem, but what would it mean for enabling the future expansion of technology itself?
That's a really complex question, isn't it?
Yeah.
It bridges energy policy, tech development, environmental challenges.
Absolutely. It's a space that's fundamentally tied to the future of both energy and technology, and definitely one worth watching. Thanks for joining us for this deep dive.